All right, you guys, for number 5, okay, we have that Ron sails his boat from point R for a distance of 150 kilometers, which is right here, on a bearing of 120, which is this 120 over there. When they say bearing, you guys, it's always you start from north, and let's say a bearing of 30 would be you count until you reach 30, okay? A bearing of, I don't know, 200, okay? You would first face north and then count until you reach 200, which would be around there, okay? So around here would be a bearing of 200, all right? So that is what bearing does. That is why it's labeled as it is. For bearing, you always start facing north, and whatever degree you get is the bearing you're going to be doing, okay? So anyways, that's why it starts off with a bearing of 120, and they arrive at point S, okay? And then he sails on a bearing of 38 to reach point T. Ronce's journey is shown in the diagram. And we need to find part A, RST. And so clearly RST is this whole thing over here. And so it's going to be 38 plus something, right? And the interesting thing about these bearing exercises is that technically you were filled with what we call parallel lines. As you can see, all of these dotted lines are facing north, right? All of these are north. That means all of these are vertical. That means all of these are parallel, okay? And you can make a bunch of different rules and a bunch of different properties come out because they are parallel. I need you guys to understand that what I'm about to do, I can do it because these lines are parallel. See? I know I said parallel like 10 times in the last 12 seconds, but it's really important you guys notice these are parallel lines, and so there's a property that comes out of that. If you have two parallel lines that cut like this, so you have one like this, and you draw a line that, whatever, intersects both, okay? A couple properties come out of this, see? So on the one hand, this angle that's in green, okay, is the same as this angle that's in green. And this angle that's in green is the same as this angle that's in green. So all of the greens are equal to each other, okay? As you can see, this right here is just a snapshot of this right here. It's like the same picture. There are no differences between those two things, okay? And so with that in mind, technically this angle here is the same as this angle here, all right? And this angle here is the same as this angle here. So all the blues are equal to each other, all the greens are equal to each other. And one more observation we can do, notice how in this straight line, how many degrees does a straight line have? A straight line has 180 degrees. And so green plus blue, so I'm just going to be very detailed. So in this case, if you do green, okay, plus blue, you're going to have 180 degrees. All right? So a straight line has 180 degrees. And so if you cut it down through the middle, you know that, or you cut it through some way, right? You know that this one plus the other one has to be 180. Okay, that's what I'm trying to portray to you guys. All right. So why is this useful? Well, because you have a bunch of parallel lines, extend them. So if you go ahead and extend these lines, so I'm going to extend one over here and extend one over there. Now suddenly you have something very similar to what's going on over here, right? Only that it's sort of like flipped, okay? But the same idea applies. So let's go piece by piece. If this is 120, then you guys, how much is this? Ah, that's going to be 120. I mean, sorry, that's going to be 180 because it's the whole angle, right? Minus 120 gives you 60. Ah, okay, so this thing in purple is going to be 60 degrees. And so if this is 60, then technically, if this is 60, then technically this one over here is 60. Now I really need you guys to see this because this step is a little bit weird, okay? But technically you are replicating this parallel lines property, okay? Just to make it more visually appealing, I'm going to plug in some colors here, okay? And so technically, if I draw out these lines a little bit more, just to make it even more friendly, notice how, remember how I said green with green are equal to each other? Okay, so this is equal to this is equal to this, whoops. And for the blue, you would have that that this is equal to this, and that this is equal to this whole thing, okay? So that is the property that I just used. Green equals green, blue equals blue. And so for RST, you're just gonna have to do 60 plus 38 gives you 98. So angle RST is 98. The way you get it is by what they call, if you want to Google it later, I'm pretty sure it's supplementary angles. If not, just put parallel lines properties and you're probably going to run into it, okay? Intuitively, just draw this image. It's probably the best way to describe it, okay? Anyways, that is for part A. Then they tell us that point T, okay, is directly east of point R. So point T is directly east of point R. So boom. Now, why might it be useful that they say directly east? It might be important that they say directly east because, now you know that this is a straight line. Okay, but this north is also a straight line. Boom. So you got one straight line going up. You got one straight line going to the side. That means that, big thing to do here. Here you have 90 degrees. Here you have 90 degrees. And so if this original is 120 and this part here is 90, that means this last sliver over there is going to be 30 because 120 minus 90 gives you 30. All right, so this is 30. This whole thing is going to be 98. All right, so this whole thing is going to be 98. And that also means that this last angle, right? Notice how I'm filling in information before I even read part B. I'm just filling in information from what they gave me. Fill in information, then try to solve it. Okay, so fill in all information. You can say that this last angle is going to be 180 because it's the sum of angles in a triangle. So 180 minus 98 minus 30 gives you that 52. So here you have 52. All right. And we need to calculate the distance that Ron sails to return directly from point T to point R. So it's the distance of X of this whole red line. Now, I've been scribbling this diagram a lot, so let me just make a small summary down here. So if I make a small summary down here, what you know is that you have the points R, S, and T, and you have an angle here that is 98. You have an angle here that is 30, I think, yes. And you have an angle here that is 52. Last but not least, you need to find X from R to T, from T to R, and you know that this is 150. All right, you guys, there's a couple tools we can use here. And depending on your approach, some of them might be more friendly, others might not. But what I highly suggest is that you consider this a trigonometry problem, okay? And guys, for any trigonometry problem, I want your approach to be the same. For any trigonometry problem, you will first try the sine rule. If the sine rule doesn't work, you're going to go to the cosine rule. And if the cosine rule doesn't work, you probably just need to get like creative and consider SOHCAHTOA, okay? When I say SOHCAHTOA, I mean sine, cosine, tangent, okay? And when I say SO, it's, just to clarify in case anyone's confused, SO is opposite over hypotenuse, ka is adjacent over hypotenuse, and TOA is opposite over adjacent, okay? I'm not going to go into this because in this video, we're not going to use SOHCAHTOA, but please remember that SOHCAHTOA is only for right-angled triangles. If it's not right-angled, you can't use SOHCAHTOA. Only use SOHCAHTOA if you have a right-angled triangle. Very, very important. Please don't forget it. All right, guys. So anyways, you're facing a trigonometry problem. The first step, you will always try the sine rule. Now, some of you are probably thinking, damn, I never really learned the sine rule. So you're about to learn it with me. If you go to the formula booklet, remember the formula booklet is one of the tools you will be having the day of the test. look up sine rule. And as you can see, you have little a, big A, until B and C, right? Let me exemplify a little bit what this means. And so there's a difference between the big letters and the small letters. The big letters, notice how they are inside sine, okay? And we're very used to seeing stuff like sine theta, right? And so theta is always used for an angle. What am I trying to say here? Whenever you have sine something or cosine something or tangent something, that something is always, always, always going to be, no matter what, an angle, okay? So these big letters are angles. And so this big letter A has associated to, side little a. This big angle B has the side associated little b. And this side big C has the side, this angle big C has the side associated little c. Okay? So point is, it works in pairs. It works in pairs of angle slash side. So as long as you have at least one pair, or like 3 of the 4 things you need, right? You can use one of these equations. Let me be a little bit more clear on that. So the sine rule says that you have little a over big A equals a little b over big B with sine, right? And little c over big sine C. So technically, because you have 2 equal signs here, you can look at it as only little a over sine A equals little b over sine B. All right? And technically from here, if you want to understand it very intuitively, all this is really saying is that you have your side, like side 1, over sine angle 1 equals your side number 2 divided by sine angle 2. And you pick which is quote unquote angle 1 or which is quote unquote angle 2. Okay? So in this case, what is the only side I have? The only side I have is 150. And what angle is associated to 150? 52. And what are you trying to find? X. And X is associated to which angle? 98. So that means you can plug in. So 150 over sine of its angle, which is 52, equals X of its angle sine 98. So if you want to get X alone from here, all you need to do is multiply by sine 98, makes this go away with this, and you end up with X equals sine 98 times 150 divided by sine 52. And you put all of that into your calculator, and you first make sure that your mode is in degrees. Okay, make sure your mode is in degrees. And from here, you just gotta do sine 98 times this whole thing, right? I'm gonna open up the fraction by pressing alpha y equals, pressing the first option, you can put 150 divided by sine 52, and this is your value for x, and x is gonna be 188.50, all right? And that is, and hold up, we are talking about kilometers. So don't forget units, 188.50 kilometers. If you want to round it up with significant figures, you would count 1, 2, 3. Do you round it up or does it stay the same? You round it up. So x in significant figures is 189 kilometers. All right? You guys, that is for part B, and that is actually for number 5. I don't find it super hard, but I do think it's awfully specific to know the parallel lines thing. Okay? And so just remember, anytime you have a bearings problem, anytime they do a bearing, you have a straight line up north. See? And all of these straight lines up north are all the same line, and so you can probably do some trick with parallel lines. All right? So that's a small but specific thing you gotta know. I think it's pretty hard to spot it, but like much in life, you see it once and you see it always. Okay? So get familiar with it. You'll never like miss it again. See? All right, guys. I hope it helped. And remember, for trigonometry, follow this process. Okay? Maybe you see a shortcut of using SOHCAHTOA immediately, and if you do your thing. But I just want to show you a process that always works. Okay? It might take a little bit longer, but it's a process that always works, and that is what I like to teach the most. Procedure, okay? Facing a trigonometry problem, first try sine rule. If not, go to cosine rule. If not, you probably gotta get creative, or you're missing information, or you can just use SOHCAHTOA or stuff like that. See? All right, guys. Now it's concluded. I hope it helped. I'll see you around. That is for number 5.